Greetings everyone. I am Uday Sharma from the Triple E Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic steam turbine models for monitoring purposes. Steam turbines are one of the most important pieces of equipment in many industries, including power generation, oil and gas, and manufacturing. Monitoring steam turbines is essential to ensure their safe and efficient operations. Steam turbine models can be used to monitor a variety of parameters including speed, vibration, temperature, pressure. By monitoring these parameters, steam turbine models can help to identify the potential problems early on and prevent costly downtime. There are two types of steam turbines taken into consideration. One is a physical model. The models are physical replicas of steam turbines. They are typically used for training and development purposes. The digital models. These models are computer-based simulations of steam turbines. They are practically used for design and analytical purposes. The physical models would be the exact same-to-same copy of the regular models which is being used currently, whereas the digital models are the digitized version of the steam turbines to in which we can perform different on which we can perform different computer-based simulations and we can get the results we need. Applications of steam turbine models for monitoring. Steam turbine models can be used for a variety of monitoring applications, including predictive maintenance. Steam turbine models can be used to predict potential problems before they occur. This allows for preventing maintenance to be performed, which can help to reduce downtime and costs. Predictive maintenance can be simply explained as the predicting the potential problems and before the problems arise and removing the problems or solving the problem. Performance monitoring. Steam turbine models can be used to monitor the performance of steam turbines over time. This information can be used to identify the areas for improvement and optimize operations. Fault diagnosis. Steam turbine models can be used to diagnose faults in steam turbines. This information can be used to repair the faults quickly and efficiently. Steam turbine models for predictive maintenance. Steam turbine models for predictive maintenance are computer-based simulations of steam turbines that can be used to predict potential problems before they occur. This allows for the preventive maintenance to be performed, which can help to reduce the downtime and costs. As discussed earlier, the predictive maintenance is maintenance done before the problem arises, which can be predicted and which can be solved. This reduces the costs. Suppose if there is a small change in the turbine which may damage any of the part, with the help of the predictive maintenance, we can predict what are the damages to be caused and how can we solve. So if we solve the damages, if we solve the problem arised, we can reduce the cost or we can reduce the cost by just so fixing it instead of replacing the whole item. The steam turbine models for predictive maintenance typically use data from the turbine's operating history, including speed, vibration, temperature, and pressure. This data is used to train the model to identify patterns that indicate potential problems. Once the model is trained, it can be used to predict the likelihood of the problem occurring and remaining useful life of the turbine's components. Here, the deep learning and AI can be used to predict the problem before it arises, and in the future, they can be eradicated or they can be skipped to occurring by learning from the mistakes or by learning from the data sets it have on the predictive maintenance. Steam turbine models for predictive maintenance are computer based simulations of steam turbines that can be used to predict potential problems before the steam turbine models for predictive maintenance can be used to predict a variety of problems such as bearing failures, blade failures, valve failure, rotor imbalance, cavitation, and erosion. Here, these all can be here, these all can be predicted before they can occur with the help of steam turbine for predictive maintenance, and they can be solved. Here, a digitized version, the steam turbine is used to conduct such simulations. As we can see, first fix when broken, then schedule maintenance activities, then defect elimination to improve performance, then advanced analytics and sensing data to predict machine reliability. This how are the different levels of the steam turbine model for the predictive maintenance. The application of predictive maintenance. A power plant used, suppose, for example, a power plant used a steam turbine model to predict the remaining useful life of its bearings. The model predicted that one of the bearings was likely to fail within the next 6 months. Then the power plant will immediately schedule the maintenance to replace the bearings, which prevented a costly outage. That is, if the bearing breaks, it may damage the whole the interior of the electronics and different other devices, which may cause a lot of cost and manwork. The manufacturing plant uses steam turbine model to monitor the performance of its turbine over time. The model identified that one of the turbines was operating below its peak efficiency. The plant was able to make adjustment to the turbine's operation to improve its efficiency. A chemical plant used a steam turbine model to diagnose a fault in one of its steam turbines. The model identified that the fault was caused by the problem with the turbine's governor valve. The plant was able to repair the valve quickly and efficiently. These are few applications of the predictive maintenance which are being currently applied in the real world scenario. Steam turbine models for fault diagnosis. Steam turbine models can be used to diagnose faults in steam turbines by simulating the turbine's operation under different conditions and comparing the simulated results with the actual results. This can help to identify the root cause of the fault and to develop a plan to repair it. The steam turbine models for fault diagnosis typically use data from the turbine's operating history, including speed, vibration, temperature, and pressure. This data is used to train the model to identify patterns that indicate different types of faults. Once the model is trained, it can be used to diagnose faults in new and unknown turbines. Steam turbines speed versus time. Steam turbine speed is an important parameter to monitor and indicate potential problems with the turbine. For example, a sudden drop in the turbine speed would indicate a problem with the turbine's governor valve or with the steam supply. As we can see in this diagram, the speed of the turbine gradually increases. But if any case the speed decreases at a certain point, this indicates that there is a fault or any problem in the steam turbine's valve or the steam being generated. Factors that can affect the speed of the steam turbine may be the steam pressure, load of the turbine, steam temperature, and valve settings. That is, if steam pressure decreases, the speed of the turbine decreases, the load of the turbine, the steam temperature, and if the valve is open to the highest setting or the lowest setting. This all may affect the steam speed with time graph or the speed with time curve. Sensors in steam turbines. Sensors are used to monitor a variety of parameters on steam turbines, including speed, vibration, temperature, and pressure. This information is used to ensure that the turbine is operating safely and efficiently. Here are some of the most common sensors used in the steam turbines: speed sensors, vibration sensors, temperature sensors, pressure sensors. Which sensors measure the rotational speed in the turbine shaft. This information is used to control the turbine's governor valve and ensure the turbine is operating in the current speed. The vibration sensor measures the vibration of the turbine shaft and bearings. This information is used to detect problems with turbine's rotating components. Temperature sensors measures the temperature of the steam entering and exiting the turbine. This information is used to control the turbine's operation and to prevent overheating. Whereas the pressure sensors measures the steam pressure entering and exiting the turbine. This information is used to control the turbine's operation and to prevent the overpressure. Steam turbine modeling is a rapidly evolving field with a bright future. AI, cloud computing, and any digital twins are making steam turbine modeling more accurate, accessible, and affordable. As a result, steam turbine modeling is being used more widely to improve the safety, efficiency, and reliability of steam turbines. Thank you. This is Uday Sharma signing off.